Well, thanks very much for inviting me. It's a real pleasure to be part of SMER's 40th anniversary, and it's always a pleasure to be here in Stockholm. You've already had a little bit of an intro. I'm Stephen Wilkinson from Lancaster University. You've already had a little bit of an introduction to our project from Andrew earlier, so I won't repeat much of that. What I'm going to try and do in this talk are four things. As I say, the first thing I will say almost nothing about. Then I'll talk to you briefly about two case studies, IVG, in vitro gametogenesis, also known as artificial eggs, artificial sperm, ectogestation, ectogenesis, artificial wombs, various names for that. These coincide with the exhibition things you may have seen upstairs at lunchtime, so it's all supposed to fit together. And then I'm going to just try to, so we've got two quite different examples there, and then I'm going to just try and bring out some sort of common themes and really ask the question, what should we be thinking about now, and what is kind of on my mind in terms of these things raising kind of interesting, worrying, exciting ethical issues. So, as Andy was saying earlier, the Future of Human Reproduction project, which is ultimately what this work derives from, is a multidisciplinary humanities and social science project bringing together lots of different disciplines. We are looking at three major sort of case studies or themes, which are ectogenesis. Actually, I'm just going to move here so I can see the screen down there. Actually, no. Okay. Is that good? Okay, good. So a quick technological reset so I can see that. So look at these three themes, and I'm going to talk about just two of those today. The first two, ectogenesis and in vitro gametogenesis. So moving on to IVG. What is IVG? Well, so artificial gametes, in general terms, this is a set of technologies that would enable us to create egg and sperm sort of in the lab, as they say, outside the human body, and these could then potentially be derived from non-reproductive cells like skin cells. There are two main techniques that have been discussed and which are ongoing programs of scientific research in order to make this happen. One of them is using induced pluripotent stem cells, and the other one is using somatic cell nuclear transfer. You may have seen very recently a news report regarding Oregon Health and Science University, who announced what they call a unique proof of concept. They've been using the cell nuclear transfer option and claim to have got some embryos to a blastocyst stage, although a caveat there would be obviously the success rate is very low, and I don't believe any of them were kind of anywhere near being sort of fit for reproductive use. Nonetheless, it has been claimed very recently that this is a breakthrough. You may have seen a couple of years ago, 2023, using the other technique, the induced pluripotent stem cells. Scientists have created mice with two fathers, which is a nice catchy headline, and you get to see a nice picture of a cute mouse. So that's kind of, I mean, there's a very, very quick overview of where we are. So, I mean, the key point to take home there is that, this is animal-based research is happening, and sort of early embryonic research is happening that could make this a possibility. This is a picture of the Nuffield Council on Bioethics Horizon Scan, which divides the future into three categories, short, medium, and long term. According to the Horizon Scan, in vitro derived gametogenesis is sort of medium term. You can see it sort of in the middle near the top. And medium term is defined as a sort of 5 to 10 year horizon. That's not a 5 to 10 year horizon for it actually happening. It's a 5 to 10 year horizon for there are things that we need to consider bioethically and possibly from the point of view of regulation. So that's widely believed to be something that we need to be looking at, in the medium term. I mean, 5 years is gone in a flash anyway, isn't it? So almost in the medium term now. And I should add that the Nuffield Council, with some colleagues of mine, also very recently produced a review of ethical policy questions related to IVG. So if you want to read a report on this, you can check that out. And some of what I'm going to say is based in part on the work that led up to that. There's three kinds of things we might want to use IVG for. I mean, there may be others that I haven't thought of, but here are three examples anyway. It could be used in fairly mainstream infertility treatment to improve or make easier existing things that we do now. So, for example, if IVG became incredibly safe and effective, and we probably are looking quite long-term here, it could replace traditional egg retrieval techniques, which involve, significant pain, risk, and inconvenience for the women who are providing the eggs. So instead of doing this, instead of doing what we do now to get eggs, human eggs, we could use IVG in principle, take a skin cell, a biopsy, and then turn it into some sperm in the lab. So that's a possibility, and if that was possible, that would have huge benefits for the IVF process. Other things which are more, if you like, radical or exciting, which ethicists often get quite excited about, are the fact that we could, and also other people who are not involved in the science still get excited about, are possibilities like having genetically related same-sex couples. So you could use this technology to get an egg from the cells of a man's body, and conversely, in theory, you could use it to get a sperm from the cells of a woman's body, and so you could end up with two male parents, two male genetic parents, or two female genetic parents. There are other possibilities that are even further from what we now do, including what's sometimes called multiplex parenting, where you create two embryos from two couples, and then you use those embryos to create to get cells which are turned into gametes, and so one makes an egg, one makes a sperm, and so in a sense you might say that those embryos are the parents of the resultant child, or you might say that they have four parents, or as Hank was saying, this could be a case where we may need to think about conceptual revision, and perhaps we haven't yet got a word for what this relationship is. The other interesting thing which often grabs attention about IVG is it could be used to enable much older women to reproduce. At the moment, obviously, men can reproduce until quite a late age using their own gametes. There are definitely recorded cases of men in their 70s and even 80s fathering children, whereas that's difficult for women with their own eggs. So you could level that playing field by using IVG to create eggs from older women. Finally, I won't say much about this, but given that IVG will make it, or could make it possible to create a very large number of embryos, it really opens up the possibility of widespread embryo selection for traits, and so it enables what Hank in his work on this has called easy PGD, where you just get a larger number of embryos, and that just gives you a huge opportunity to have easier, more effective, and more extensive embryo selection. Okay, so that was a whistle-stop tour of IVG. On to ectogestation. So it's like these, it's called a lot of different things: ectogestation, ectogenesis, artificial womb technologies, artificial placenta technologies, all slightly different, but in a similar sort of ballpark. It's important to distinguish full from partial ectogenesis. So full is where you go all the way from conception to, well, it wouldn't be birth, but the creation of a child, whatever point that is. And partial ectogenesis is where the fetus starts off in a sort of natural pregnancy, but then is removed and placed into a artificial womb type device. Teams in the US, Australia, and Japan are all working on this. You can see pictured on the left there one of the quite famous media pictures of a lamb in a biobag. These lambs back in 2017 were reported as having been this is partial ectogenesis, having been gestated for about 28 days in that sort of biobag, which aims to mimic the sort of womb environment. And I'll skip through that. Again, back to the horizon scan. So ectogestation is widely believed to be a much more, well, at least full ectogestation is widely believed to be a much longer term prospect. So again, on the Nuffield one, it's more than 10 years, but I think it'd be a lot more than 10 years in humans. Although incremental improvements in prenatal care using this kind of technology, so partial ectogenesis, could be here, much sooner than that. But it's nonetheless worth considering now. I think firstly because, as Hank mentioned at the end of the talk, things happen unpredictably sometimes. And, there are various technologies which could converge to make ectogenesis technically possible. Also, from a more kind of social cultural angle, there's a huge amount of interest in this topic. I mean, I haven't done a sort of systematic survey of this, but there seem to be lots of kind of cultural references to ectogenesis coming through. Obviously, Brave New World is not new, but there's been quite a few novels and films and so on about ectogenesis recently, and some of which we've looked at in the context of our project. So, in terms of engaging with the cultural discourse around it, I think it's something we should do and take seriously. I'd need a very long talk to do a proper survey of the pros and cons of ectogenesis, but I'll just mention a couple. One clearly, as I've already mentioned, is that it could be used to extend and improve neonatal care, and so it could save the lives of preterm infants or could improve their quality of life and their chance of good outcome. It could enable a wider range of people to have children, so it could be used instead of surrogacy, instead of uterus transplants in those kind of cases where people would otherwise need to use those or might not even have an option. For a long time there's been a sort of emancipatory argument put forward about ectogestation, about what it might do to society, of freeing women in particular of the burdens of having to carry children. So some theorists obviously have posited that one of the reasons for sex inequality is the fact that women have to do the gestational labour associated with childbirth, and this is costly, risky, negative in various ways. So that's I'm not saying that myself necessarily, but that is a school of thought. And finally, some people have argued that it would be a better alternative than conventional abortion. So rather than terminating a pregnancy for whatever reason that might be, you could extract the fetus, put it into an ectogenesis pod, an artificial womb, and then the fetus/child could then survive. Flipping over to the negatives, while people have expressed concerns about well-being, mother-fetal bonding, the abortion point around ectogenesis can go both ways. So just as some people have argued that a positive feature of ectogenesis is that it will mean that some of these fetuses that would otherwise be aborted survive, the flip side of that is that this could lead to a significant erosion of reproductive rights and abortion rights, the argument being that if fetal extraction, where the fetus survives and adopted as a possibility, it may become less socially or politically acceptable to have a conventional abortion. Again, how you take that argument will very much depend on your own perspective on the abortion debate. And more broadly, I think ectogenesis raises concerns, going back to the Brave New World scenario of gestation itself being commodified and industrialized and taken over by big business or big tech. Final thing on ectogestation I want to say is just to flag some of the project work we've done with linguists on the project. So this is just a slight methodological aside. So as well as working with speculative design on the project, we've been working with literature, psychology and other colleagues, but we've also worked with some colleagues who are corpus linguists. And in case you don't know, corpus linguists basically look at large bodies of language data and analyze it using some sophisticated analytical software that they know how to use and I don't, so we've been working with them. And what we did for our sort of pilot study was compare the way bioethics articles talk about this topic with the way that people commenting on YouTube videos about ectogenesis talk about it. And we actually found that there was a good degree of similarity actually in terms of obviously the language is very, very different, but there's a degree of sort of overlap and convergence, particularly around arguments related to autonomy and the fact that ectogenesis could promote equality and avoid harm. And also the links to the abortion debate are there. However, it's important to say, and this is probably not very surprising at all, but unlike the bioethics literature, the YouTube video was very, very misogynistic, and a lot of comments were saying that ectogenesis would be a way of replacing women and making them obsolete and irrelevant. And so there's one example of a quote there. A person said, "This is beautiful, this is how we can make women become obsolete." And others commented on how women could be replaced by a combination of sex robots and artificial wombs. So I guess the reason to flag that is just because I think it's probably important just to think about how And there's lots of methodological caveats about what inferences we can draw from that. But I think it's important to note that, how these technologies responded to sort of outside the sort of ethics environment is perhaps very different to how we might think or at least talk about them. So, common issues and themes. So that's two examples. I mean, I raised these examples because I think they're interesting technologies that will raise very interesting issues, and also they are kind of worth looking at now, because even though we're uncertain about the extent to which they might be rolled out in practice, there's enough evidence to suggest, there is a plausible future world in which these things could happen, and it might not be that far away. So, issues and themes. Both of these things have got the capacity to contribute to very radical change, really remaking in a very deep way how we reproduce. Secondly, I would say, and maybe this is true of nearly all technologies anyway, I think that's how they're used is how they would be used, could be used, should be used. Perhaps that's the big issue, rather than whether there's any intrinsic feature of the technology which is good or bad. I think in both cases you can imagine these things being used for very good purposes, and you can imagine them used in a totally dystopian way. So I think we've got to try and work our way through not so much is this a technology which is good or bad, but how can we use it, if necessary, restrict it and constrain it to make it as positive as it can be. The third thing, and this goes back to the YouTube comments a little bit, I think it's important that, as well as bioethics, we have to have significant levels of public engagement and public attitudes research to answer the ethics and policy questions, because we need to know, or need to have an informed opinion about how these things will be received by actual people, how they will be used, how people want to use them, what it will do to people's values and language and discourse. Next, I think one thing that's notable about this area is that the questions raised aren't just ethical, and here this I think links up to the previous talk. The issues raised aren't just ethical, they're also conceptual and linguistic. So in the case of ectogenesis, it's already been mentioned, what do we call the being which is inside an artificial womb? Is it a fetus, a fetonate, a gestataling, a baby, a person? What do we call it? And similarly, in the case of IVG, if somebody has 4 genetic parents, well, is that the right term? Are there 4 genetic parents, or are there 4 grandparents, or do we just need a whole other set of terms for this? So what counts as relatedness? What counts as being a parent? Those kind of questions, I think they're all going to be thrown in, or could be thrown into some disarray by this technology. One thing that I think might follow from that is this could change the evaluative significance that people place on genetic relations. I think very often genetic relatedness anyway is a bit of a placeholder for something else. People talk about genetics, but I'm not sure it's always what they really mean, or genetic links. Perhaps they're referring to something else, like belonging to a family or some other broader concept which needn't be understood in a biological way. But anyway, if our concepts of relatedness, family, parent, baby, and so on, if these are really shook up, it could change the sort of values that people have around biological relatedness. Right. So, almost at the end. The only other themes I wanted to pick out on, and I think this may come up in the next talk a little bit, that the idea of, both IVG and ectogestation, although they're not necessarily primarily aimed at doing this, they could be gateways to easier and more widespread enhancement and selection of future generations. So I've already mentioned IVG could create huge numbers of embryos, which could then be selected amongst. But ectogenesis as well could be used in a sort of enhancement where you could have an enhanced fetal environment. It could give you an opportunity to do more intervention. So essentially, if the fetus, call it a fetus, is in an artificial womb, it's probably easier to manipulate the environment and to even do things like fetal surgery and fetal medicine in that situation, rather than having to do it while it's inside a living human woman. As ever, access and funding are likely to be big issues. Should any of these things be publicly funded? If not, who can afford it? Who's going to get access to it? Will it lead to more injustice because of an unfair playing field in terms of who can access the technology? And finally, I think a big concern has to be what would the role of commercial actors be in shaping access to these technologies? Will they be taken over by big tech giants, and will reproduction be, as I said earlier, industrialized and taken over by large companies and preventing fair access by the rest of us? Going back to an earlier talk about the right to science, I think this very sort of engages there. So there are more questions than answers, but I better stop there, and there you go. Thank you.